So in this video, I'm going to show you how to sort. Okay. So how to write a Java program to sort. So we start out with the numbers, list of numbers, and also list of names. So I want to create a sort that only one sort that can support different type, right? Could be string type or double type. So in order to do that, we have to use the concept we call generates, right, in Java. And so you may see the sort itself. Okay. So the sort itself, the method sort here has the T type here. So this is starting to use the generates. So T like type. Now, how do we use this? Like, for example, when I create a class named sort with the T type. So you may see when I instantiate the object sort from sort, right? I need to, we call parameterize it. So give the type to it. So in this case, it's double. So then that sort can use for double. Because I want to sort this, but I don't want, this is a double list, but I don't want to rewrite my sort for string and so on, right? So now let's test this program first and see if it's showing sorted correctly. This is in order, right? So after I instantiate, I say it's going to sort double. I just say sort dot ascending and pass in the array of double in, right? And loop to see the output. This part of code is not related. I'm going to take it down. So now let's run this program first. Oh, okay. So I'm about to explain. So T is type, but when we don't know the type, like if it's numbers, it's easy. If it's not the number, like the reason we want to make generate, it can sort an object too, right? Could be sort a car by price, sort a car by engine size. Then an object should extend. This is the concept of inheritance. So extend a comparable. So comparable. So what's comparable? Comparable pretty much just like I said, when it's extend, that make that object be able to compare. So let's take a look at comparable Java doc. Comparable is pretty much an interface. So we talk about interface again. So an interface is you're not implementing it. Because comparable is going to have one method name compare to. That's it. And the reason you're not implementing it, like think about the object. Like I said, a car can sort by price or by engine size. How would you know? It have to leave to the programmer or the business, right? To decide. Programmer just sort and implement it in there. But to use this at this point, we just extend comparable. Then we have an access to compare to in order to compare. Now let's talk about the logic to sort. Okay, after I run this. So it just sorted the numbers, right? So this is minus 4.5 sorted in order. So that I don't really need this system.out. I put it there just to test the program. So let me rerun this. Then you understand output. Alright, so minus 4.5 is lowest and it's sorted in order. Right? And this is the list, which is out of order. Now let's look at logic. So I pass in this list, right? This list of number into ascending through this method, right? Dot ascending. And since we use generic, so T, we don't know the type that can support any type, and return T type back. In this case, it's going to be double because we parameterize it right here. So I'm going to sort it double. So the first loop here, pretty much just loop from the index 0 operate, list dot length, right, to the last minus 1. We're going to talk about y minus 1. Let's look at the second loop. So first loop pretty much just going to loop through the list. And what's the point of that? We said I is here. So I equal to 0, that means the first number 13.5. And I'm going to say the second loop going to take the next number to it. Because 0 plus 1, which is take 2.1. Pretty much the second loop make compare, right? Compare your first number to the list. If you look at, because I compare, then there's no reason for me to put 0 or equals to I here. I don't have to compare to itself. Then I compare to the next number. And compare the next number because the second loop pretty much is the loop from the next number to the end. Right, dot length. And what I try to find is just compare. There you go. I start to use compare to. That's from comparable. That method to compare. So if it's less than 0, that means the number is smaller. The number means 13.5 is smaller. But if it's greater than, that means it's bigger. Right? If it's less than 0, it's smaller. If it's greater than 0, that means 13.5 is bigger. If it's equal to 0, then that means it's equals. So if I found that this number happened to be smaller, then I pretty much just swap it. Swap, like for example, list J actually refer to I take 2.1, right? Compared to the min. Min in this case is compared to 13.5, right? So we see that 2.1 is smaller than 13.5. Right? So this if is going to be true because less than 0 right away, right? So you take 2.1 compared to 13.5. So it's smaller than, that means I need to exchange this, right? Swap the location. So, and I also need to update. My min now is no longer 13.5, it is 2.1. Right? So I update min is now 2.1. And then swap. Swap pretty much just exchanging the location 2.1, 13.5. I create a method for that by passing the index, right, of min, which is the first min is was 0, and j now is 1. And the list that I want to swap, so let's just take it into temp, and then list j equals to list I, and then temp, put it back. Right, so just replacing the value swapping. So pretty much after we swap, then it's take the 2.1 again, which is the new min, compared to, because we're not finishing this loop yet, right? Compared to 9.7 and minus 4.5. Now minus 4.5 where it start to be less than 0 again. So it's just execute this again. If it's true, then your new min is minus 4.5, and then you swap with location 2.1, because 2.1 now was in the first location, right? After the first swap. Second swap now minus 4.1 go into that location. Right, and do the same thing through the loop, which no longer true because 9.7 and 12.6 is no longer true, right? So at the end, you pretty much just have the list that had the smallest number right here, which is minus 4.1. I mean minus 4.5. But you only did it once. You still need to make sure the rest is also have to be sorted. So that's why the first loop, right? Increase I to 1 is starting to do that, the highlighted subset, right? But I don't need to include the last one. You see I have minus 1. It's only due to here. And the reason, if you think about that, that's same, it's going to get into the second loop. And it's going to sort that. Now it's going to get smaller, right? And smaller, right? And at that point, it's only this one compared to that one. Then there's no reason to take the last number to compare to itself. So that's why I subtract 1. Then we get a list that's sorted. So that's the logic. Okay. And the reason we use compare to make it support any type. Right. Normally, if you use number, you don't need that. You just do less than this number, less than the other number, right? But this one, we want to do any type. Like, for example, let's test with if I pass in a string type now. Alright, so pretty much just put this. So I'm going to create another, right? String sort, and just parameterize this to string type at this point. Instead of double, we can now do the string, because T pretty much just take the type string, right? So sort ascending, now I'm going to do names, right? Dot ascending. String is an array of names. Ascending. Oh, has to be string sort, right? Because sort belongs to that double. Create a new object. Alright. Now, support string. And I don't need to rewrite the whole code for string. So that's how you create a method and make sure it supports any type. That's how you should design. And now, let's do loop. For, now this loop is pretty much just loop through your array and print out the values for each. They also have, instead of using this, we can do for each. So for each looks like this. For an array, you can use for each. So this is an array name, and you just declare the type and with the variables and print them out. Right. So now the type is string. Okay, v values, and colon for each of the array names, for each element of the array. So we're going to pretty much just print out the element. V. Alright, so let's run and see. It's already sorted. Let me make sure this is not a sorted list. Dog, elephant. Alright, so it's not sorted. So after we run this, it's supposed to sort the list for us. And be cat dog 11, right? So if you want to have the new line, you can just do ln, right? So you see that by